how many distinct real solutions x are there to the equation? Okay, a bunch of nested things, blah, 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 squared, 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 squared. Okay. 5, 6, 7, 8, or 9. I'm not going to read this out. You can see it on the screen there. I'll write it here, though. Not sure exactly what my intuition is on this one, but maybe we sort of just work backwards from, you know, we already have something squared is equal to 4. So we know that x squared minus 1. Okay, so, well, I won't read the whole thing out, but this squared minus 3 is equal to 2 or negative 2. Okay. And maybe we can continue just by keeping track of the fact that this thing can have 2 possible values. So this is equal to 5 or 1. Okay. So then x squared minus 1 squared minus 2 is equal to plus or minus root 5 or plus or minus 1. So we're up to 4 considerations here now. In fact, let me write it like this. Okay. And I can add 2 to all of these. And now I see where things take a bit of a turn. So this is negative, right? Root 5 is a little bit, square root of 5 is a little bit greater than 2. So 2 minus root 5 is negative. So we're not going to get a real solution anymore, at least. I mean, so it means this is purely imaginary. Take something purely imaginary, add 1, and take a square root. I'm not going to get something real. So now we can cross that off. And we're left with x squared minus 1 is equal to plus or minus root 5 plus 2 under square root plus or minus root 3 plus or minus 1. And it looks like we're going to get another root knocked off because 0 seems to be, 0 is going to be, it's going to have multiplicity. So, and it's asking how many distinct real roots are there. So if I write this out, I now have x squared is equal to, I'm not going to, you know, there's 6 options listed here, but I'm not going to write them in a list of 6. I'll keep them in a list of 3. So I have plus or minus root 5 plus 2 under square root plus 1. I have plus or minus root 3 plus 1. And I have one plus or minus 1. Okay, so we have another possibility of getting a negative number. So let's cross off the ones that, oh, a few of these could be negative, couldn't they? So the negative sign here gives us a problem. The negative sign there gives us a problem. So let's write this as x. Now I'll list out all the possible things we can have. We'll have root 5 plus 2 under root plus 1, root 3 plus 1, 2, and 0. Okay, now we have no problems. 2 roots, another 2 roots, another 2 roots, but this only gives us 1 root. So 1, 2, 3, 4, 5, 6, 7. I believe the answer is 7 then, which is option C. I hope I did this correctly. It's really just, I suppose, keeping track of the relative magnitudes of some of these things under square roots, seeing if they're greater than or less than the corresponding thing that you're adding, and then crossing off options that don't work as you go. But yeah, I think that would be the correct answer, and in fact, you'd be able to list all the roots out. I suppose, going through this, you could write as a complex number. How many roots would this have in total? 1, 2, 3, 4, 5, 6, 7, 8. No, it's 2 times 2 times 2 times 2. So, this thing, I suppose, would it have 16 roots? Yeah, this is a degree 16 polynomial. So you could write out because it's written in such a sort of convenient form where you can just keep, the squares are kind of completed for you. You could write out all 16 roots and just maybe deduce pretty easily which ones are complex and which ones are not. But yeah, I'm going to go with 7. I'll let you know if there's a mistake somewhere. Thanks for watching.